Graphs of the sine, cosine, and tangent functions represent the values of these ratios for given angles on a coordinate plane. By now you should be able to sketch the graphs of sine, cosine, and tangent with little thought or effort. You should also be able to identify the important features of each of these graphs. By that I mean the domain, range, amplitude, period, and so on. Nadia, here on the board we have a chart that's designed to help us identify those characteristics for each of these three functions. Let's start off with the domain of the sine function.
Well, theta can be in the set of real numbers for sine.
Okay, so in other words, there are no undefined values for theta.
Okay, and the range is y can be between -1 and +1.
Inclusive.
Yeah, so y is in the set of real numbers.
Right, all the real values between -1 and +1 inclusive.
And it has an amplitude then of 1.
Right.
And a period of 2 pi.
Good. Cosine function.
It has a domain again, theta in the set of real numbers.
Okay, again, no undefined values.
And its range is y can be between -1 and +1.
Inclusive. And again, y is an element of the set of real numbers. Good, so we've got a minimum of -1, maximum of 1.
So its amplitude would be
Right.
1.
Because the amplitude is 1/2 of the...
Distance between the minimum and the maximum
Right.
points. And the period is 2 pi.
Okay, so again, it takes us 2 pi radians to complete one cycle of the graph.
And for tangent then, the domain would be theta's in the set of real numbers, except theta cannot equal pi over 2, or pi over 2 plus any multiple of pi.
Right. And what happens at those values?
There's an asymptote.
An asymptote, which means that the function is undefined for that value of theta.
So theta cannot equal pi over 2 plus n pi.
And n
is a member of the integers.
Right.
And other than that, theta is in the set of real numbers.
Good.
Okay, and the range for tangent is y can be anything in the set of real numbers.
Right. So there is no maximum or minimum for the tangent function. So what about the amplitude then? If there's no maximum or minimum, do we talk about the amplitude of tangent function?
Not really.
No. The period is?
Pi.
Right. So notice the differences then between the sine cosine function as opposed to the tangent function. There's nothing there that's the same. However, for sine and cosine, we see that all the characteristics are the same. What is different about the sine and cosine function?
They have different theta and y-intercepts.
Right. Let's take a look at a particular function. We're asked to graph a transformation of y equals sine theta. We're given the function y equals 3 sine 0.5 theta plus pi over 4 minus 1. Now, there are many different methods of graphing transformations. We could do a mapping, we could draw a curve, and then assign our axes and our scale. What method are you going to use?
I kind of just go through one step at a time doing each transformation so that you can see the graph and see how it changes.
Right. Okay, so you're going to start with?
I'll start with the change in the amplitude.
Okay.
So the amplitude is changed to 3.
All right.
So all points, like all the y points, will be multiplied by a value of 3.
Right.
So the new graph will pass through these points.
And that's the graph of y equals 3 sine theta.
Okay, and then next I would take care of the new period of it. The 0.5 means that the period will be stretched out. So all the
By a factor of?
2.
Right.
So all the x values will be multiplied by a factor of 2. So this point here would now move to pi.
All right.
This point here would now move to 2 pi.
Right.
And this point to 3 pi. And there. So your graph would look
And that then is the graph of?
y equals 3 sine 0.5 theta.
Good. So we've dealt with 2 of the parameters. The
Okay.
third?
Is the phase shift.
Right.
It's moved pi over 4 units to the left.
To the left.
So everything would just be moved, shifted over to the left.
Right.
Pi over 4 units.
And you're working now with the blue graph.
Yeah. So it would just pass through all the red points. These red points here.
Right.
And for the last one, last transformation, you just have to move the graph down by 1 unit. So
Taking all the red points then and moving them down 1 unit on the y-axis.
So your final graph would look like this, and it's y equals 3 sine 0.5 theta plus pi over 4 minus 1.
Right. Now that we have the graph of our transformed function, let's compare its properties with that of the original function y equals sine theta.
Well, the new graph has an amplitude of 3 compared to an amplitude of 1 for y equals sine theta. And the new graph's period has been multiplied by a factor of 2.
Right.
So it's now 4 pi compared to 2 pi. And the new graph has been phase shifted pi over 4 units to the left. And it's also been vertically translated 1 unit down.
Right. And what changes do those
It'll
parameters affect?
It'll affect the y-intercepts and the theta intercepts.
Right. As well as the range of the function is now -4 is less than or equal to y is less than or equal to
2.
2. Remember, you may also get questions in which you're given a function and asked to determine its equation. In other words, you need to find a, b, c, and d and express that function then in the form y equals a sine b theta plus c plus d. Whichever method for graphing the transformations of the sine and cosine functions you choose, remember it is not only important to know how to graph the function, but also to know how to describe its characteristics.
Let's take another look at our sketch which shows the daily time of sunset at Yellowknife. We can use this sketch to approximate answers to many different questions. For example, what is the time of sunset on the 240th day? The answer will be found by tracing up to where the graph is and across, and we'll see that it's at about 2000 hours or 8 p.m. For a more accurate answer, we'd need a more precise graph. On the other hand, if we knew the formula of the curve, we could use it to get a more exact answer. Here's the formula. Now, it's not too difficult to understand how this formula was obtained. The horizontal axis has been scaled in days rather than in usual degrees or radians. Y in this case stands for the time of sunset, and N stands for how many days have passed after December 21st. In relation to the basic cosine curve, we can see that our curve has undergone a vertical shift of slightly less than 19 units. It's being translated 172 units to the right. And finally, we can see the amplitude is about 3 hours 48 minutes, or 3.80 hours. Using the formula to find the time of sunset on the 240th day requires substituting 240 for n. This gives a decimal answer of about 20.38. Now, 0.38 hours is approximately 23 minutes. In time units, that means 2023 or 8:23 p.m. That is the time of sunset. Later on, we'll look at the graphs for sunrise time and hours of daylight.